everything, right? So let's go through a few questions. So what kind of jobs are available for me after graduation? I think this is a valid question. I think most students, they have in their minds what exactly they are going to work as. I think multiple choices, and because material science is quite diverse, that actually means that you are able to apply in a different variety of jobs. Okay, but we'll go through it in the first segment of this webinar. Right. So what is the salary range like for MSc students? So well, that's actually a tough question. I'll just let I think our keynote speaker Prof. Benjamin, to discuss this with you. Any research opportunities? Yes, of course. Because material science and engineering is one of the most research intensive department. Of course, there are a lot of opportunities that you can take. Like there's undergrad research opportunity program. There's of course internship program, and of course I think there are very simply just a final year project. Right. So curriculum structure, yes, you will get to know the curriculum. We have listed out an overview of what you will be doing over that 4 years, right? So no worries about that. Please just listen up when we go into our first segment, right? Hands-on practical session. There are actually a lot, so a lot of hands-on practical session. I bet it will be fun because when you first enter into material science, we have a couple of modules that involve like lab works. But do not worry too much. It's more of a team-based lab work, so you will get to work together as a team. So it's actually an enjoyable experience for most. Right? What do you learn in MSc? Well, I think we'll cover it in the curriculum structure. I think that would be easier for us to look into. All right, physics background, right? So if you do not have physics background, well, I think Prof Blackwood will be explain this to you.
Maybe I'll mention it now.
Yeah.
You do need an equivalent for O-level physics to get into the engineering courses. You don't need A-level physics, but you do need the equivalent of O-level physics, right? So that's a requirement to get into engineering. But if you don't have the A-level physics, you can do a bridging module.
Yep. Okay, so I guess we can start. Rather small audience here, but let me just start then. All right. Where's my? Hang on. Oops. This is... Okay. So a good day to everyone. I think this is a very beautiful Sunday, and I'm glad that you are spending it with us. Okay. My name is Vincent. I'm a teaching staff at Material Science and Engineering, NUS. So I would like to welcome all of you in taking part in this webinar. So here I will just put Material Science and Engineering as just material MSc. I think it's easier for us to understand it. But I want you to also to look at it in this perspective, where the M stands for to make a difference. Right, S stands for to see the future, and of course E as the engineering tomorrow, right? So the agenda for today, we have 3 segments. Because we are a bit short of time, so I would like to just go through quickly. So between now to 3:10, we will have the first segment, which is to give you a brief understanding on what material science is all about and how can it impact the world, right? How do we influence the applications and the industries with material science? So within this first segment, we'll embed materials challenge quiz. So it's just a fun quiz. It's a competitive quiz where you stand a chance to win attractive cash voucher. So this is just for fun, right? So please just stay with us for the first segment. Then the second segment, we'll move on to students' experience sharing section. So that is where you get to understand how, as a material science undergrad, what do you get to do? What do you experience a day as a material science student? And perhaps the rationale of why they choose material science as their undergrad course. Right, then eventually we'll move on to the last segment, which is between 3:30 to 4 p.m., where we have alumni sharing session. So that would be important if you are considering like career opportunities. So you want to see how material engineers works, then that is where you want to be, right? And lastly, we have this AMA, which is Ask Me Anything. So make sure you join us there. So finally, there will be a raffle. It's just a fun little thing that we're trying out. So there'll be a raffle at the end of the session. So what that means, right, is after 4 p.m. or rather before 4 p.m., we'll randomly pick a winner from our attendance, our audience, and he or she will stand a chance, right, or rather will win a cash voucher, right? So that's the plan for today. So let me just introduce the keynote speaker for this session. So our keynote speaker is Associate Prof. Benjamin. So he is our Associate Prof and Deputy Head for Outreach in Material Science and Engineering. He is a recipient of multiple prestigious awards like National Research Foundation Fellowship, Singapore Stanford Biodesign Global Innovation Postdoctorate Fellowship, and a few others. So he obtained his PhD from Stanford University, and he's the core inventor of electronic skin sensor technologies. So if you watch CNA, Channel News Asia, you might have seen him presenting, right? So let me welcome Prof. Benjamin to share his talk. Prof. Benjamin.
Okay, thank you, Vincent, for the introduction, and welcome everyone to this afternoon session of the E-Open House. I hope all of you had a good lunch and are ready to find out how MSE can help materialize your future. So material science and engineering has been, is a name that probably has shaped history. And because of that, it will also determine what lies ahead in terms of technology. Why do I say that? If you look at materials, every one of us interacts with materials today. Your cell phone, for example, has a lot of materials technology in it. But when we first started as a human civilization, right, we really first made use of materials to protect us from the environment, like using stones to build shelters and for very basic structures. However, as we start to learn what nature has provided us in terms of the different elements and the different materials, and also their properties, it has allowed us to engineer various applications. So we can turn a very simple raw material, such as sand, into the billions of transistors in your cell phone, right? Materials have defined eras in human society and technology. Moving forward, materials will play an ever-increasing role in biomedicine, right? For example, all of us have now been given most likely what we call an mRNA vaccine. And the reason mRNA vaccine actually is now working is really because biochemistry and materials engineer have figured out how to actually encapsulate these little bits of proteins into a cell of fats surrounded by fatty molecules. And these then allow it to be delivered into your cells for the vaccine to work. So you can see that understanding materials and engineering them for various applications have tremendous implications for your future and maybe even your children's future. So learning about material science and engineering, you will learn critical knowledge that will power many major industries. MSE, right, is truly an interdisciplinary science, right? We actually teach physics, chemistry, and biology. So if you like physics, but also like chemistry, right? MSE is a good combination. If you like biology, but maybe you're not sure if you want to be a doctor, MSE can provide the foundation for you to learn about biology and then apply that to engineering applications, right? You can actually develop tools and machines for medical science and doctors to use. So impact can be far greater. The combinations of the basic sciences and the knowledge to engineer them into applications, right, can be very important in a few areas I've highlighted here, such as biomedical technologies, artificial intelligence, AI, green technologies that will hopefully combat this climate crisis that we are facing, and also other advanced technologies like robotics and new semiconductor materials like 2D materials and nanomaterials. So there are many, many more applications once you can harness and combine and blend physics, chemistry, and biology together. And in the application of engineering principles that we will teach you, right, to create technologies in these different industries. Here, I just highlight some of the major ones that our graduates have gone on after they graduate. The semiconductor industry, right, is a very big industry, close to $1 trillion investment, right? What the numbers here, what these numbers mean, right, is really is a reflection of how much resources, right, that society is placing on careers, on people, on machines and technology, right? So it's a reflection. So the higher the number, the more resources, the probably better paying careers, better career progression, and so on. So semiconductor is a very big industry. AI is growing, right? It's about now close to $500 million. Green technology will become more and more important. How do we, for example, perform better carbon capture or capture water from the environment? We have faculty, Professor Tan Sui Cheng, who does that in our faculty. Also biomedical applications. So MSc is really a very fundamental science and degree program that really can allow you to do have a very diverse career choice, right? Our graduates have worked at big companies like Micron, Google, ST Engineering. If you like research, we have A-Star, P&G, Consumer Technologies, environmental agencies, and also medical technologies like Johnson & Johnson. So you may ask, well, is it really true, right? This seems too good to be true. So I did a very quick Google search today, right? And I found some jobs that are available for material science and engineering graduates, right? For example, Nike, right, actually has a materials manager that actually is looking for materials innovators, right? You can see even anything from footwear, right, that big brands that you're used to are hiring materials science and engineering students with that kind of knowledge. Of course, Apple, this is Apple Singapore, also has open positions for materials engineer. And of course, these are very big companies with very good career prospects. And because MSc is a very unique degree program, you will not be competing with very big cohorts such as those in mechanical engineering or BME and other types of very traditional engineering disciplines, right? And so that sort of sets us apart. The importance of material science and engineering also is perhaps one reason why we have the first Nobel Prize laureate, Sir Konstantin Novoselov, or we call him Kostya for short, to join MSc at NUS. He's the first Nobel laureate to join an engineering department in Singapore, and he is fascinated by the opportunities, right, to create new materials and change their properties, right, for different new types of applications. And he is actually leading an institute at MSc for that I'll share a bit later. So we have different specializations, and these specializations are specially designed. We have Professor Dan Blackwood here, who is the head of curriculum, have specially designed with the entire teaching team, specializations that cater to the emerging industries as well as traditional industries, so that you can have a very good career. For example, biomedical technologies. We have specialization in AI. We have specialization in polymers and soft materials, as well as nanotechnology. And here is just below each of these specializations, I have provided a list of some of the modules, titles that you will learn if you choose these specializations. Now, before we go into the details of this degree program, I will hand over the time to Dr. Vincent to have a very short and fun game segment.
Yep, thanks, Ben. Well, I hope it will be short. All right, so let's do this. So everyone, please go to the Poll Everywhere website that I shared with you, the link. Right, so this is a very fun, I guess it'll be fun and a bit of a snippet of what you will probably be learning in material science. And I think these are just the tip of the iceberg, right? But I hope that you can join the fun. So maybe I'll do it this way. Can you, if you're able to join, just give me a thumbs up, right? Just give me a thumbs up so I know you are in, all right? I will hate to miss out anyone. Yep. Okay. I see one. Maybe a thumbs up or any indication is fine. Okay. Raise hand function is fine too. Yeah, please. Yep. Great. So you stand to win some cash voucher if you are the first place, of course. So please be careful because this quiz is mostly on the accuracy, but at the same time, speed counts. So make sure you're able to do that too. So everyone else okay with the quiz? Who wants to take part? Just fun one, don't worry. Okay, I guess we should start. All right, let's start then. Okay, first question, right? So which of the following materials is the smallest? Okay, in terms of the size, smallest. So you have 30 seconds to answer this, right? So look at the questions and the answers carefully. Maybe some of the words have already given its answer already. All right, last 5 seconds. All right, cool. Okay, no more answers. All right, quantum dots, good. So most of you know is quantum dots. So for those who chose polystyrene, microspheres or virus, don't get too worried because I think they are also quite small, right? So this is just to show you how how big the particles are. So the first image on the left shows you a quantum dot is about 3 nanometers. If you look at the scale bar, this is about 2 nanometers. So of course, a quantum dot can be smaller than that, of course. Then you have the virus. The virus, 60 nanometers. The polystyrene microsphere is about 400 nanometers. This is a microscope technique that you'll probably be learning, or rather you will be learning and doing it for yourself when you are in our course. And lastly, you have the SAN, which is 2 millimeters. So that's how the size is. Okay, cool, right? So second question, which of the following materials is the best thermal conductor? Right, I think that's actually a quite straightforward question. So I think thermal conductivity is one of the material properties that we will have to learn as material engineers, right? So of course, during the course, you will learn the theory behind the thermal conduction. How is it being? How can heat be transferred from one to the other? All right, cool. So we are done. So I think most of you all choose steel. I suppose you all have heard of graphene, right? So graphene is actually the answer here because if we look at purely from the numbers, right? So from the numbers, in terms of thermal conductivity, steel has a thermal conductivity of 54 watts per meter Kelvin, right? And diamond Diamond is about 400, and graphite is 470. So surprisingly, if you were to exfoliate using the graphite, you exfoliate it and make it into a 2D graphite. I'll just call it 2D graphite. Then it's graphene. Then you get about 10 times increase in the thermal conductivity. So one fun fact, I think Prof. Benjamin has already mentioned that the inventor of the graphene is currently with MSE. So if you are interested, I mean, you may have the opportunity to drop by his office and have a good discussion with him, how graphene can conduct heat that well. Okay, right, cool. So we have someone leading the pack, okay, but you still have a chance, right, to catch up. All right, just this is going to be a long one. I'm going to just show you the video. So this video, the third question is based on this video, okay? So this video is about the shape memory material. So this is a very interesting, let me just mute the thing because this is a very interesting material where the material can remember its original shape, right? So in this demonstration, what this guy is doing, right, is to show you there is this memory, shape memory alloy. So when he distort it or deform it, you can see that you just stay as per it is, right? But then when you start to put it into a hot bath, about 60 degrees Celsius, yeah, it will just return to its original configuration. So this is pretty cool, right? Now the question comes, right? So we have this film. This film is a shape memory polymer. So it's made out of the same material. So outside, when it's cold, it's hot. When it's cold, it's rigid. When it's hot, it's a bit flexible. And then you can eventually pull it and deform it. Okay, you can deform it in this way. So the question comes, let me see where I can just. So the question comes, based on the video that you have saw, what do you think will happen to the stretch material when it is re-immersed or immersed back into the hot water? Okay, so what do you think the material will happen? What will happen to the material when it's placed into the hot water again? Okay, you have certain. I mean, it's just a clue, right? Because it's a shape memory material. Okay, cool. Awesome. Okay, cool. So let's, yeah, I think you guessed it, right? Because it's a shape memory material means you will just remember each shape. So let's see how the demonstration of how exactly it is. Let me just move this about here. So this is the one that is deformed. Then what happens next, right, is that we are going to put it back into the water. Let's see what happens. Okay, I hope this is a very cool phenomenon. I can assure you it's not, we are playing the video backwards, okay? It's just that it just recovered its shape, all right? So this is just one very simple material that we use or we teach in material science, okay? Okay, good. So let's move on to the, I don't know, fourth question. So do you still remember the days when we are young, we play, I'm not sure for this generation, you still play with soap bubbles. No, you use the detergent, you make the soap bubbles, you can blow it and it become bubble, right? So, but in material science, you can use the soap bubbles as a liquid membrane. All right, so what's the good of liquid membrane? You can filter particles. So here, which of the statement is correct? Just follow your gut feeling. So what happens if I have particle penetrating through this soap bubbles? Or I should call it the film. Right? Come on, you only have 5 seconds. Okay, cool. That's great. All right. So I think most of you got it. So it's all about surface tension. I'll not really explain too much here because you will still be able to learn this if you were to select one of our module, which is I think materials on biointerface. So let me just show this this experiment that was done. So on the top, they are releasing some nanoparticles, not really nanoparticles, but powders, right? And you have some smaller, bigger particles here. So here, this ring actually have a layer of the soap detergent, right? The film. So you can clearly see this is it penetrates through, it passes through without popping the film, while everything else is being captured. So this is pretty cool because of the idea of surface tension. Okay, this is also one of the important knowledge that you will gain from material science. All right, cool. Okay, we have a very clear, not very clear actually, we still have a chance. Okay, I think it's the last question. So how can material science be applied to medical or medicine development for cancer treatment? So please choose the right one. So of course, material science is not only regarding like energy, sustainability and whatnot, right? But more I think closer now towards medicine. It is very important that we use material science to develop right carrier for medicines, right? Okay, yeah, great. So all of the above. So I mean, material science, when you develop a medicine, you will need to have a way to allow this medicine to target a specific cell, of course. So how do we do that? We can only review it in our course. Of course, there's going to be a very long module anyway. So other than that, I think you all got it all right, lah. All right, excellent. So, okay, that's that for our quiz. So can we note down who's the winner? It's a very close call. So CH, you're the winner. So please, the winner CH, can you please email us at askmse@nus.edu.sg? Then we'll review more information how you collect the prize. All right, we'll send this contact in the chat again. All right, thank you. So let's move on to let's continue with Ben's.
All right, thank you, Vincent. For can you hear me?
Yeah, I can.
All right, thank you, Vincent, for the I hope you had a good time with the special game segment. Congratulations to the winner. Okay, so I'll continue sort of describing more detail about the department. Right, we have an award-winning teaching team, and we are, in fact, we have a faculty who's actually the NUS president, right, Prof. Shi Junfeng in our department, and we have, of course, the Nobel laureate and many top-notch professors and teaching staff, many of whom have started companies and have won many different awards, teaching awards, research awards. So because of our, because we are quite, selective in this program, we have always consistently tried to maintain a good student to faculty ratio, roughly about 3 to 1 student to faculty ratio. And in terms of male-female ratios, we are close to 1 to 1. But it fluctuates historically. Generally, I think we are one of the higher male to female, balanced male to female student ratio departments. Our graduates have gone, here are some of their faces, have gone on to various industries, not just in technology. We also have in consultancy, we have Elizabeth Tan, who we've invited to be alumni speaker as well. In some of our YouTube videos, you can find online. She's an analyst at Accenture. Vishnu, right, is an entrepreneur of an AI startup, and many others, in different disciplines, right? To this morning, we had Jeremy Koh from ST Engineering. He's now a manager. So we have designed the curriculum, right, to be fairly flexible. You'll spend about a third of your time in a common core curriculum. And of course, Professor Dan Blackwood will be able to speak more about that later. We'll have we have another about a third in the major requirements, and almost a quarter, actually exactly a quarter, to be able to use for any electives that you want. They're unrestricted. So you can take modules from computer science, you can take modules from other engineering departments, or even in business school, and that is really the strength of NUS as a diverse and very large, broad-based type of university. And in terms of specialization, I've already highlighted, right? So for those who join later, we have biomedical specialization, AI specialization, polymers and soft materials for those who like a lot of chemistry, and nanotechnology for those that like to like a bit of physics and also want to learn about semiconductor science and technology. All right, so I'll let Professor Dan talk about this slide. Right, this slide really charts out, roughly speaking, how your 4 years will look like. So Dan, you want to give a quick segment here?
Yeah. Okay. So I'm Dan Blackwood. I'm the Deputy Head for Education. Okay, so this is essentially a route map of how you'd go through your degree. The purple ones, so these purple colored ones, or sort of purpley blue colors, those are your major degree. So they're the MSc ones. Okay. The white ones, you'll see a lot of unrestricted electives. Those are, you can basically choose anything you like in those. But many of you perhaps will like to do a minor, specialization, or even a second major or double degree, and that's where you will do those. Okay, you can basically do a double degree there are now literally sort of hundreds of choices in MSc between double majors, not in MSc, in NUS, double majors and minors. So almost anything you like. You can do a double degree in 2 engineering subjects, or you can do a double major MSc and say business or physics or something like that. The other colors are the core modules. Okay, so if you look in the first year, you'll do modeling simulation, which is essentially mathematics, design thinking, project management, and data literacy. Okay, and the only module that you will do from MSE, and it would be the same if you were in another engineering department, is what we call engineering principles in practice. Basically, this is to try and get you in the lab and teach you the fundamentals of materials. In the first one, we will teach you the fundamental chemistry and physics you need, and as an introduction to the materials properties. And in the second one, we'll start to teach you the foundations of material structure, mechanical properties, and again, so you get a broader knowledge of the different categories of materials, what makes one material different from another. You also do a little bit more modeling, again, a little bit more mathematics. The digital literature one here is actually computer programming. You will learn Python there. Okay, there was a lot of debate whether it should be MATLAB or Python. In the end, the faculty decided on Python, is because more practices engineers are now using Python over any other computer language. When you go into your second year, we will teach you, we used to call it thermodynamics. Now we're calling it foundations of renewable energy. What we're trying to do is changing our curriculum to give you more case studies to explain why you need to learn about these particular topics. Thermodynamics materials is rather dry on its own. So by linking it to renewable energy, you immediately will see, okay, this actually does have a real life application. It is useful for me to understand all about Gibbs energy, entropy, and things like that, because they are actually useful in helping me design a better battery or to store energy. You will also have an artificial intelligence module that's taught by the faculty. Later on, we will have options to learn artificial intelligence within our own MSc modules. Then the only other MSc module you normally do in the second year is electronic materials. The reason we put that in there is there are lots of properties of materials, but the semiconductor industry is a very large employer. So we still feel that electronic properties is amongst the most important ones that you need to learn in Singapore. Perhaps if we were in a country which had a large iron and steel industry, we might have gone for mechanical properties there. I mean, perhaps an interesting fact that came out of the quiz just now was that you noticed diamond was actually a good thermal conductor. But it's actually a very poor electronic conductor. If you think of metals, they conduct electricity very well. They also conduct heat. And most materials that conduct electricity also conduct heat. diamond's an oddity. It conducts heat well, but not electricity. So you will learn why in electronic properties of materials. It means that diamond thin films are very important to us in industry. We're not talking about diamonds that you wear in an engagement ring. With a thin film of diamond, it's very important to us in many of applications when we want a layer that's electrically insulating that will allow heat through. Okay? Then you'll move on to material characterization. Material characterization, basically you will look at the building blocks of all types of materials. So if you have a material, if you can characterize it, you can see what it's made out of, then you can start to guess what its mechanical properties will be, or its chemical properties, or its electronic properties. Materials characterization is also important in failure analysis. In fact, it's one of the most important jobs that material scientists do, is figure out what is a material made of, or if it's, when we're doing failure analysis, how did it fail? Then you also will do kinetics. The thermodynamics always tells you what will happen, but you don't know how fast it will happen. Diamond is another good example. Diamonds are thermodynamically unstable, but they hang around forever because they're kinetically very stable. But kinetics say how fast something will go. You also have some more unrestricted electives. So again, that's time that you will be able to do the your minor or your second major. These GE modules, by the way, these are there's a university pillars. So these are things like Singapore studies, community studies that give you a general broader education. Then you will go out onto industrial attachment. We have a 6-month industrial attachment. You will be able to come back to the university and do some modules as well in the evening. Actually, probably you'll be able to do a technical elective from MSE here as well. We do offer some evening modules to allow students that are on industrial attachment to come back to NUS and study a module in the evening, so that you can still keep up with the number of MCs. Our students go to a wide range of companies. We've had students go to Rolls-Royce, some go to ST Kinetics, so they go into the real engineering, Micron Semiconductors. So there's a wide range of companies have taken our industrial attachment students. And then in the 3rd year, we'll have a lab session. Okay, the materials characterization, by the way, is taught both as labs and lectures. Okay, so there's labs there, right? So there was labs, a lot of labs in your 1st year, labs again in your 3rd year, and then in your 4th year, we'll have labs on materials property and also a lab on machine learning. So you have a hands-on experience of how machine learning helps you design new materials. And the other thing that you will do in semester, what are we now, semester 7, is materials selection. Whenever you're a material scientist or engineer, and you often be asked, what should I make this out of, right? Well, it's not an easy question to answer because there's hundreds of thousands of materials. So we need a systematic way of choosing what is the best material for a particular application. And so you will learn how we choose the best material for an application. You will also do either a research project, you can do an individual research project, or you can do a team design-based project. Okay, this will, if you're doing a double major or in an engineering, this will count towards both your MSc degree and your degree that you're doing in the 2nd engineering department. And then the other time is electives. So you will do, that will give you a chance to start doing the specializations. If you do a specialization, you need 20 MCs, so you'll need to use up a little bit of your unrestricted elective space as well. Okay. In addition to the ones that Ben has already mentioned, we've just submitted a specialization in microelectronics and quantum materials, which is important for the semiconductor industry. And we're in the midst of preparing one in sustainability and engineering. It typically takes about a year to get them approved through the university, and they have to go all the way through MOE. But you won't really start taking the modules in that until at least your 3rd year. So by the time you come to us and you get into your 3rd year, you'll have a wider choice of specializations. The biomedical one that we've already mentioned, that's actually, we designed that with the Department of Biomedical Engineering. So you'll take some of our modules and some of their modules. So you'll get real medical experience when you take that specialization. We've already got, and the nano ones are already mentioned, the polymer one, and the artificial intelligence one as well. So by the time you get there, there will be, I think, 6 specializations. I think that's covered this slide.
Okay, thank you, Dan.
Okay, thank you.
I guess now there is a good question. Maybe I'll just like to quickly ask here is how do you get the best of both MSc and BME, and what are considerations about which major or minor? We can choose to answer it now or later. Dan, feel free to.
I could unmute myself. Whether you
I'll let you
decided
read
to,
the question first.
yeah,
I'll continue. Yeah. Okay. So thank you, Dan. In terms of employment rate, I think we have very good employment rate despite the pandemic. For the past 2 years, we have been getting over 90% employment rate for our graduates. In fact, we are now, in terms of MSc, we have the highest salary for MSc degree holders in Singapore, right? And it's also important not just to look at the this column. All of you may be familiar with this table by now, but basically you look at the employment rate. There's 2 columns: employed versus in full-time permanent employment, right? So we have very close to full-time permanent employment for our graduates, and I think this is also important column to really look at, because if you look at only this column, there could be some part-time employment, right? So if you consider degree programs, if you look at salary from a salary point of view, definitely do also consider the full-time employment rates. So, our graduates have gone to do various things, right? Vishnu has started a company, and he says that the community and culture in MSc is pivotal, right, to his career and innovation, especially in innovation. So he actually raised quite a big amount of money for his company, Invigilio, right, on AI and safety. Our students also do very exciting stuff across different domains. For example, biomedical, right? We have a student team that won the James Dyson Award, right, the international one, and this is the first time a Singapore team actually won this award in 17 years of this award's history. Right? They basically developed a glaucoma type of sensor for glaucoma management by measuring eye pressure at home. Right? This is because they have the diverse knowledge from materials to sensors to AI that they're able to come up with this solution or concept. Actually, I would like to add that actually students from my group and undergraduates doing various FYP and so on have also contributed to this, right? So the other aspect is we are now launching several exciting awards, study awards for incoming graduates. Sorry, we have the Sir Konstantin NOVOSELOV MSc Study Award for some of the best students that apply to us. So if you apply to us, you get very significant sponsorship in terms of financial incentives for your degree program at MSc. Of course, also you can also list this in your resume. Besides the Sir Konstantin NOVOSELOV Study Award, we also have started a new study award for all students, male or female, right, to apply to, right, that recognizes first-year incoming MSc students. So if you are very interested to join MSc or considering between MSc and various degree programs, this is something. This is one of the pros to consider for joining MSc. We have many different programs, enriching programs for our students. They participate in visits to different companies, such as ST Engineering. We have Jeremy Cole here, hosting us. And this is really the reason is because we have very strong alumni networks in Singapore and international, right, in various companies. And when you join MSc with the degree program, you are immediately part of this big family of alumni that we have that are all in various positions, senior positions, leadership positions, right? And also you get to join very active student groups in MSc. Right, right now we have over 1,000 graduates working both in Singapore and overseas. We have several YouTube videos where our alumni will share their experience on how MSc has helped in their careers. So if you're interested, you can check out the YouTube videos or our Instagram or Linktree, right, for all these links to all these videos. So I think MSc allows you to know the how and the why of how technology actually exists and how they can progress. And because you know the how and the why, you're going to be taking likelihood of taking leadership positions in your career is very high. Why do I say that? Here's an example, right? We have the this person. I hope most of you are probably familiar with his face. He's actually the CEO of Alphabet or Google. And turns out his degree, right, undergraduate degree, is in material science and engineering, specifically metallurgy, right? So because I think that this kind of interdisciplinary training and thinking really helps you build a strong career and advance the career ladder, right, that you choose to be in. So we have also the first institute dedicated to functional intelligent materials, co-directed by our Nobel laureate, right, Sir Konstantin Novoselov. We are a top-ranked university, right, on top 5 universities ranked in the world. And importantly, for your career, we are the #1 in terms of employer reputation in Asia for a degree program, which means that even before you graduate, employers will start to look for you, and you may have a job before you even get your certificate. And this happens to some of our students, right? So there are many talks we have already hosted, right? They are all online, and if you have interest, you can check this, scan this QR code. There's one more remaining by our alumni, right, on March 2nd. All right, you can also go to the website to find out more. Right, we have a Telegram group if you are interested to talk to an admissions advisor. We also have a page talking about all the different things we have spoken today in detail at this admissions interest group page, and you can actually leave your email for us to link up further. All right, so I think I have come to the end of our my slides, and I'll let Vincent take over from here.
Okay, thanks, Ben. So let's just move on to the next segment. I think the next segment here is the MSE undergrad sharing session. So please do listen up if you have any queries regarding student life, or how do they feel about material science studies. I think this is a good chance for you to understand a bit more about how they feel, right? So I think let me first introduce our speaker. So our first speaker is Joel. So Joel is our second year MSc student. Maybe I'll let him introduce himself. I think that would be better. So Joel, could you please share your experience with our audience?
Yep, sure.
Okay.
Thanks, Prof. Vincent.
Yep.
Let me just share my screen. Okay, so hello everyone, I'm Joel. I'm a year 2 MSE student, and today I'll be sharing about my experience in MSE regarding the curriculum and also the student life. So yeah, I added a meme. This is just to point out that within all the engineerings in NUS, I think MSE is one of the 2 that also has science in the name. So yeah, just something interesting. Okay, so a bit about me. I'm 23 this year. I'm year 2 MSE undergrad right now. I'm taking a minor in computer science, and I'm also hoping to upgrade to a second major after this sem. Previously, I was from Pioneer Junior College, and I took physics, chem, maths, and econs. I'm also a recipient of NUS Merit Scholarship, and I'm in a couple of casual CCAs, as well as assisting MSE Club with the freshman orientation program coming up in July. So yeah, if you join MSE in the future, you might probably see me around over there. Okay, so let's get into why I joined MSE. So MSE really came to me as an option when I was during secondary school, when my teacher just mentioned it to me. And because he was a very influential teacher, I looked up to him a lot. So I took his suggestion quite seriously, and I continued looking into it. In JC, I also did relatively well for physics and chemistry. And so I wanted to go into a related field. I wanted to go into a field, a more scientific field. But what really attracted me about MSE when I started looking into my options was how incredibly diverse it is, and how it has applications in all different kinds of industries. So just an example for myself, Previously in JC, my first interest, my first love, so-called in MSE, was regarding nanomaterials. Okay, and why that was because it had a lot of publicity. It was very popular at the time. There's all these YouTube videos showing, for example, if you take a piece of pencil lead and then you take Scotch tape, you stick onto it, and then you peel off the Scotch tape, how a piece of graphene will be left onto the Scotch tape. So that was nanomaterials, and it has so much publicity and bling around it, and I was very attracted by that. But as time progressed, and especially after I moved into NS, because I was trained as a medic, so I started thinking about how materials is also very relevant there, and how, you know, because we had to learn anatomy during the medic course. So I was thinking that how you know, for different kinds of injuries, that materials is actually very relevant in also biomedical applications. Recently, as I gone into uni, as you all know, I'm taking a second minor in computer science, and so I'm looking more towards the coding aspect. So artificial intelligence. Now what I'm looking towards is using artificial intelligence to progress material science research. But the nice thing about material science is that regardless of where my interests lie, whether it's nanomaterials, biomedical applications, or even AI, these are very diverse fields from very different ends of the spectrum of engineering. But no matter where my interests lie, material science is always there. Is still material science. And this diversity, this applicability in all industries is what really attracted me about material science. Okay. It also was more interesting than some other competing options that I had, and looked fun. I'll elaborate a bit more on that because, yeah. So one of the publicity events I went to, they allowed us to use some old phones, and they put it under a machine to test the Vickers hardness. So if you don't know what that test involved, basically they take a sharp tip, a kind of drill or just a diamond stud, and then press it into the phone, or they press it into whatever material you're trying to test. After that, you take it out, you see the size of the hole that it left behind. And by measuring the size of the hole and comparing it to how hard you press the tip into it, okay, you can determine how hard the material is. So that was my first kind of experience with proper lab equipment, not just Bunsen burners and stuff that we have in secondary school and JC, but this actual, like, you know, research lab equipment that people are actually using in industry. And I thought it was really cool. And we spent like half an hour, 45 minutes, just putting random things into the Vickers hardness machine, and also other machines that they allow us to try out, just testing various properties. So I really enjoyed that experience. And that's also one of the major reasons why I decided to join. So what is my experience with the MSE curriculum so far? Okay, just to let you know, my experience might be slightly different from your experience because I'm still following an older syllabus, but in general, I believe it will still feel something like this. So my year one, I focus mainly on clearing prerequisites and faculty level requirements. What these faculty level requirements are is skills that's more general to all kinds of engineering and not just materials science and engineering. So for example, design thinking, or just learning how to make something with your hands. This is something I did back in year one, the module EG1311 design and make. We had to make a robot that was able to clear an obstacle course and also serve some real life function. So this robot is inspired by the game Rainbow Six Siege, okay, where it's supposed to go into this enemy base, scout the area, come out after that before soldiers rush in and do what they are supposed to do. So this is just something that our team did for that mod. In year two, we focus more on MLE theory, so material science theory. We did, for example, crystallography. We did thermodynamics, And really, we also had some lab mods. So this is something that I did during the lab, maybe just 2-3 weeks ago. This is paper viewed under 1,500 times magnification, viewed under SEM. And when I saw this, I was quite amazed because it looked nothing like what I was expecting. When the scale is so zoomed in, it looks really sick, and then it's not something you see in everyday life. And I thought it looks a lot like the quantum realm, you know, when Ant-Man went inside the, yeah. So, these are some things that we are still doing. I'm still doing in year 2. So it's focused more on theory and more on lab work. And year 3 and year 4, year 3 is more for your internship, and year 4 is for your FYP. I haven't done those yet, so I won't be going into too much detail. So my thoughts on the MSE curriculum is there is going to be theory. Those cannot be avoided. Sometimes you learn about crystallography. It's going to be a 3-hour lecture, and it might not feel, it might feel a bit, for lack of a better word, a bit dry. Okay, but this theoretical knowledge allows us to understand practical techniques much better, and it does open a lot more doors for us to play around and explore interesting things that we actually care about. And when we put the theory into practice, when we see the implications the theory has on real life applications, that's when it becomes very worth it. So for example, electric vehicles, there's a Tesla. The batteries inside the electric vehicles, are we able to, for example, instead of using a liquid electrolyte, use solids as electrolytes, use solid to conduct the electricity, kind of. So if you want to do that, you need a solid understanding of crystallography. And you know that if you have a piece of crystal, if you introduce some defects in the piece of crystal, then those defects might be able to conduct electricity through electrons or even ions. Okay. 3D printing, what are its limitations? 3D printing is used to, or a few years ago, it was another buzzword that everybody kept throwing around. But what are its limitations? Can it print everything? And people say it's additive manufacturing is a technique that requires no waste. Is that really true? Or this is printing plastic. Are you able to print metals, 3D print metal parts using 3D printers? So by understanding principles of, for example, solidification, which was one of the mods I had to take as well, I'm better able to understand like where these limitations are, what it can and cannot do. And lastly, these are quantum dots. So these are nanoparticles. Just now, I think it also showed up in the quiz. Yeah. So besides just being an interesting research topic, what are the actual applications of nanoparticles in real life? So by altering the size of the nanoparticles, you're actually able to let it emit different colors of different wavelengths. So it shows up as different colors. And if you can control that, you can use it to make fancy things like very nice television screens, for example. So by learning all this theory, you actually see the world through a new set of lenses. You actually, it gives you more options. It gives you more things to see. You see more things, and it gives you more options for you to continue to mess with and explore the things that you are passionate about. Okay. Moving on to student life. Okay. In MSE, you are actually quite free to pursue other goals. Okay, there's a lot of things you can do. For example, if you are more inclined, if you are more interested in the social aspect of uni, okay, you can join CCAs, you can join clubs and societies. Okay, you are able to join a hall and experience RC life. You can also plan for camps and plan for other special events like Run NUS or NUS Biathlon, or you can either join or plan for it. So if you are more into that, there's things for you to do as well. Okay? Or if you're more inclined academically, you can spend your UEs to pursue a second major or minor. you can, you have research opportunities as well. There's something called Europe undergrad research opportunities. Undergrad research opportunities where you are attached to a PhD supervisor and you can shadow them on their research. You can choose to work part-time, and there's a lot of other niche programs and activities for you to choose from. So one thing I'll add for regardless of which course you go is that you are free to tailor your university experience to suit your interests. Okay? All these programs exist. All these programs are there for you. And if you don't take advantage of them, they are still going to be there, but the only one that's going to lose out is you. So don't be afraid to look for these programs. Don't be afraid to ask. And whoever is in charge, I'm sure they'll be more than willing to accommodate you. Okay? And just a few final thoughts from me about other things that really impact the university experience, even though it doesn't, even though it's not really publicized a lot. In MSE, we have a very small cohort size, and this leads to a very tight-knit community. So everybody knows everyone else, everybody depends on everyone else for support and for help. So it makes, for example, doing projects a lot more enjoyable. The profs are also very approachable, very available. You email them, they will generally reply very quickly, and they'll be very helpful, very willing to help. Okay. They give out a lot of welfare from MSE Club and Engine Club, and there's also a lot of resources available to make your study environment more conducive. So you make use of free NUS gyms, you can make use of empty classrooms, you can make use of meeting rooms that you can book. Okay, all these resources are available to make your stay in NUS more enjoyable. Okay, besides that, there's also the SU option. It's just if you do badly in the mod, you are given the option to waive the grade. Okay, this one is not really publicized a lot, but it's something that really impacts your university experience in a good way. If you fail a mod, you don't need to, okay, not fail, but if you do badly in the mod, you don't have to be that stressed about it. And also the food in Techno Edge, which is the engineering canteen, is really good value for money. And I think it's the best value for money anywhere around in NUS. So the parting thought I will leave you with is there's many things you can do in university. As I showed just now, you are free to pursue all these things. But there's also many things you can take. The resources of the university are also there. Okay, empty classrooms, meeting rooms, whatever resources, all the care packs, don't be afraid to take them. Don't be afraid to take free stuff. Okay, these things are prepared for you and for you to take advantage of. So yeah, by making use of this, you can make your stay in university so much more enjoyable, so much more conducive. And that is actually what I wanted to say. And thank you for giving me this opportunity. And I hope to see you guys in MSE in 6 months.
Okay, great. Thanks, Joel. Really enjoyed this talk. So we'll leave the Q&A for the students later on. I will have one more student speaker. So let me do this. Like I'll introduce our second speaker, student speaker. So she is Alisa. So Alisa is our final year MSc student, and more interestingly, she's holding a second major in innovation and design program. So if you're interested in doing material science and also trying out the second major in innovation and design, I think she's the one that you want to listen out for. All right. So could you please welcome Alisa to share her experience. Alisa?
Oh, okay. Hi. Let me just share my slides.
Yeah, please.
Okay. Screen. Okay. So hi everyone, my name is Alisa. So here's a little more about myself. But before we start, if you have any questions that you want to ask in future, my Telegram handle is attached there, so feel free to message me. So currently I'm majoring in material science with a second major in innovation and design, which is basically design thinking or product design for those who do not know. And I was from Nanyang Poly, Nanotechnology and Material Science, and I graduated in 2019. So currently I'm a year 3 student. And currently I've been staying in Raffles Hall for the past 3 years, and hall life's really fun, and you get to make lots of friends and try out new CCAs there. Mine was mainly videography, photography, and graphic design. So why did I choose NUS and MSE? So the main reason for me is because it's a mix of many things, mainly chemistry, physics, and engineering, as mentioned just now. And because I would like to call myself jack of all trades, so I thought this major was perfect for me. So firstly, I'll address why I chose MSE. Because it's a multidisciplinary and can be applied to many fields, as mentioned. And I also find it really cool, especially how different materials behave in nanoscale. So one example is as shown. So all these are the same materials, but depending on the particle size and dimensions, they can appear as completely different colors. And I also find the smart materials, as Dr. Vincent mentioned during the quiz just now, about the shape memory alloy and how it works. I find it quite cool. But these are just surface level stuff, and it gets more interesting as you dive deeper into the topic. So as to why I chose NUS is because they offer the Innovation and Design program, which is, as mentioned, my second major. And one of the things I've enjoyed during poly days were like the projects and how I can apply my problem-solving skills, creativity, and technical knowledge to produce working prototypes. And IDP allows me not only to do just that, but also provides me the resources, advice, and support along the way. So I'll show you some of the projects that I've done in the later slides. NUS also has the MSE Club, which allows me to be able to interact with my peers, as they are more to university than just academics. So personally, I would want to enjoy the last step of my education journey thoroughly, experiencing new activities along the way. So I've made very valuable friends along the way who has helped me in times of needs, especially because I have short-term memory and tend to forget things, so they will always remind me of things like module registration and upcoming tests or assignments that are due. And lastly, I wouldn't deny that NUS rankings have also affected my choice, with NUS being known around the world, providing countless and excellent research opportunities. So I'm sure many of you are wondering what it's like to be in uni, so let me share about it. So some things I particularly enjoyed about MSE so far is the hands-on work that we get to do, which includes lab sessions. So there are several lab modules that you get to take, as mentioned. So these modules are solely based on lab work and reports, so it's actually pretty fun for me. And these are some of the lab work done during the MSE lab mods, which includes 3D printing, the cell test, hardness test, and UV spectroscopy. And I've also done some projects as well for IDP, which includes a year-long project for self-balancing motorcycle and some CubeSat projects under the space system module. And currently, I'm also working on my final year project, where it is more related to MSE, which is on lightweight rims for the NUS FSAE race car, as the scope explores different materials to be used and using simulation to analyze the results. So I actually have to apply the knowledge learned from MSE to analyze which material is best suited for the rim. However, I felt that I was not doing enough projects and wanted to do something more beyond my academics, and that was when I decided to enter competitions to gain more exposure in the field. So needless to say, the technical knowledge gained from MSE has helped me a lot. So the first competition that I joined was P&G CEO Challenge in January last year, which was a case comp. So my team and I were one of the 3 national finalists, but we didn't win any prize. So since I was like a sore loser, so I decided to join another competition. And then this cycle will continue, which is why I ended up joining like a lot of competitions. So the next competition I joined was Schneider Electric's Go Green Challenge, and my team came through as Singapore Brunei Malaysia cluster champion and regional finalists. But unfortunately, we did not make it through the regional round. So our idea was basically for this sustainable challenge was organic solar cell implemented on greenhouses and various other applications. So funny thing was that in poly, I actually hated this module on solar cell, but this competition have made me have a better understanding of the solar cells, and I slowly grew fond of it. And the next competition I joined was IDA 2021, which is IDA. So this is more related to IDP. And this is where my team only had 3 days to come up and pitch our solutions to the problem statement that they provided. So for this, my team emerged as first runner-up, which I thought was not too bad. And currently, I'm the finalist for Samsung Solve for Tomorrow competition, where my team's idea was connecting OPV to organic battery in case of oversupply, and it's also connected to an asset management system for optimization and an integrated application. So actually, the results are out, but then I can't mention it because they haven't finalized it yet. And I also re-entered the Snyder Go Green competition this year with the idea of a carbon cycle using a carbon dioxide stripper and basalt rock dust for a natural carbon sink. So mainly I joined back this competition because I was salty that I didn't get through the regionals last year. So hopefully I can get through this year. So all these competitions will be blasted out in NUS email. So you can keep a lookout for it and hopefully win some money. I also have like several internship experiences. So far I did 2 internships during the summer break. And actually NUS has a portal called Talent Connect where you can apply for internships which can be used. But personally, I don't really use it. So the first internship was with Scorpio Electric where I did like materials research, simulations, and proposed design changes to their electric motorcycle prototype. So since it's a startup, I did some ad hoc photo taking and video taking as well, since I had some experience in doing so. And last summer, I also did an internship at DSO National Lab. So this internship was actually on researching on oxidation protection coating and ultra high temperature ceramics. And as for the upcoming summer internship, which is this May to August, I'll be working at HP on their multi-jet fusion 3D printers. So I've come to the end of my presentation, and hopefully my presentation intrigued you about MSE and hopefully to see you in the course. Yeah, thank you.
Okay, thanks, Alisa. I think it's very interesting. And it's I think we are very proud that you have you're in the finalists for the Samsung innovation, right? I think this is just one of the examples that how our MSc students can shine in big events, national events, right? So I think that's one thing, or a testimonial of how well our students are exposed to applications, the material selections, and everything else. So I think because we are planning to do the alumni, we're going to invite alumni to come in and share their experience, but unfortunately we have some technical issues. So instead of doing the alumni sharing, we're trying to resolve this issue first. So let's do AMA first, right? So you can ask us anything, ask me anything, right? So can I have the panelists to switch on the camera, can unmute yourself. Then feel free, go on to the quiz. Sorry, I'm saying quiz. Go on to the Q&A, right? Go on to the Q&A, and you can type in your question. Okay, we will not know who type in. Don't worry. Okay, you can choose to be anonymous. Okay, it's fine. Type in the questions, and we will answer them right now. But at the same time, I will ask you not to go away because we do have a raffle coming up very shortly after this AMA. So if you are here, then we will do a random picker. So we will randomly pick one of you because 8 of you, right? So you have a high chance of winning. Cool. So maybe we look at the first question. All right, the first question, right? How to get the best of both MSc and BME, right? So what are the considerations about which to select as major or minor if I am not going for double major or degree? So maybe then
you basically have a choice of doing one of the other as your major, and then a specialization in the other, a minor in the other, or doing both as majors. Turns out if you do 2 engineering majors, you get a double degree. At least that's what the Vice Dean told me last time I discussed it with him. Which to do really depends on your depth of interest, right? Specialization gives you the sort of the minimum glimpse, and minors a bit more, and a majors even more. But it takes up more and more of your UEM space, right? When we showed the curriculum that you'd go through, you have a lot of UEM space. So if you do a double major, those are the only subjects you're going to do. So if you had an interest in learning Japanese or something like that, you wouldn't have time for that. if you do a minor, you have more time to do some other interest. If you do a specialization, you have even more time. In fact, you could probably do a specialization in biomedical materials and perhaps a minor in physics or chemistry, or it could be in some other topics, or hundreds of different minors. So it really depends on the depth you want to go to. So it's really going to be a personal choice. There's not really an optimum. It's what depth do you want to learn both topics. And there's also, as one of the students said, there's more to university life than just studying. So if you go to the double major, it's good on your CV to have a double major, but you've had to work hard and maybe you've missed out on the social life. So it's a personal decision, I think, how you want to go. I think that's the only way I can answer it, really.
Great.
Yeah, thanks, Dan. Just to add, also, I think it also depends on how broad and whether you want to go, right? If you want to be a bit broader in your career options, then in terms of the type of curriculum and flexibility, right? MSE does give you a bit more flexibility and also career options. Just because you're a little less specialized relative to BME. I think then, right? I think it's fairly safe to say that.
Yes, I would agree. I turned mute again.
Oh, okay. Yeah. Great. Thanks.
All right. I think that's yeah, great. So we do have one more question here. So I have heard that this NUS is merging engineering. Is it true? So if you look at our logo right now, there's a College of Design and Engineering. So maybe Dan, you want to give a brief.
Yeah, the Faculty of Engineering merged with the School of Design and Environment, and that made the College of Design and Engineering, which is what we now are. It's actually made for students, it's actually giving you a wider choice. You can now do easier to do design modules. It's also one of the reasons we now have our core curriculum. You'll see in there things like the project management that's taught by the School of Design and Environment, and there's also some design modules in there as well. So it's helped us to broaden the core, but it hasn't really affected the major the MSE, right? We're still the same MSE department. There's no merger of all the engineering departments together. It's a merger at the faculty level. It's like two companies coming together. At the top management, there's changes. They're actually for the lower level where the real work is done, we don't really notice a big difference.
All right, I think let's move on to the next question. Next question is, does the entry cutoff remain the same or will it be increased due to the merge?
What will happen is there will be a single entry point for all of engineering, with except the computer engineering. The reason they take computer engineering out is computer engineering is now so popular that if they had a single entry point for all of them, we'd only have computer engineering students, I think. So with regard to materials, it's difficult to say because we sort of had a pretty close to the average cutoff point within engineering before. So I suspect it won't really affect the cutoff point for our own department that much. But now there's a single cutoff point for all engineering departments outside, as I said, the computing one. But whether it goes up or down really depends on the quality of the applicants.
Okay, so any other questions that you want to direct to our students? Anything with regards to the student life you're not sure about? Right. Well, take this opportunity. I think we are all here. We have the staff here. We have students here. I think it's a great opportunity here that we can discuss it openly. Right. Okay, maybe we just wait for a while, maybe a couple more minutes while I share the screen regarding some survey. Let me draw out the presentation slides. Okay. All right, so this slide, really hope that we can have all of you to help us with this. So there are two, okay, I think I spelled it wrongly, but I got two QR code for you. Okay, the first QR code is a survey that can really give us ideas how to improve on our session. I think that's important, right? And the second one, the one on the right, is a formal invitation for all of you to join us live during our open house at 5th March 2022. Right, that's next Saturday, right? So you can scan the QR code. If not, we will put in the link in the chat, so you can just click on it. So you will be able to come down to NUS and you'll see us in person, and you'll get to play with our prototypes. So you heard about the Dyson Award. It's very prestigious, but have you ever tried out yourself, right? So I think this is one thing we want you to come down and try it out. Okay, and I think we also have a few devices that are quite interesting and some games available, some prizes too. Really hope that you can join us here. So when you click the link or scan the QR code, you will see that the registration has ended, but please do not worry. All you need to do is just to join the wait list, right? Just put in your information. I'm pretty sure they will open up some space for our students. All right. So
If you don't feel that you are not able to join the physical open house, you can also follow us on our IG page. I key in the chat, live updates or anything. You can just PM us, and we will answer your question shortly.
Yep. So just leave the QR codes on the screen for a while. I think we have one more question coming in. Maybe we can discuss on this. So may I know what are some of the postgraduate opportunities after completing the MSc degree? Right, then you wanna start off?
The postgraduate ones.
Yeah, postgraduates.
If you're postgraduate, you have the option of either doing more coursework and do a Master's of Science by coursework that we offer, or you can go into research. The majority of our students local students tend to choose the research. They either do a 2-year Master's by research, or they do a 4-year PhD by research. To get onto the PhD, you need to keep your grade point average above 4 out of 5, and then you have to get a scholarship. There are various sources of scholarships. Some come from MOE, some from A-STAR, but most now are tied to grants. So you would basically choose which professor you want to work with, and hopefully he has scholarship money to fund you. That tends to be the difficulty, whether is there money to fund you. But you also don't have to stay at NUS. We've had students go overseas. Some have gone to MIT, Oxford, Stanford, Cambridge, Northwestern, and so they've gone to many of the top schools overseas. So your NUS is now at one of the top ranked universities in the world. So when you apply to a top university overseas, that makes a difference. It very much helps you get into their programs. But usually it's always a matter of, is there a scholarship available for you? Unless you're very rich and can pay it yourself. But it is expensive to do a PhD. It's out of your own money.
Okay. All right. So I guess that's that because we do need to end off by 4 p.m. So I think the last thing that we want to do is remember the raffle we are talking about. yeah, we need to do it. So
Yeah,
Edie, you want to,
okay.
yeah.
So all the
I
names
think
are here.
some of them left, right? Whoever
But I
is
think
here.
okay, so let me just double check the name again. I think I have just give me a minute.
Glenia is she's not here.
She's not here.
Yeah.
Oops. I think there is double entry for Harini since she come in both our AM and PM session. So you stand double the chance. Give me a minute. Let me check. Maybe can everyone confirm the names are all in?
Claire is here. Harini, yes. Jehan, yeah.
Okay, that means these people.
Joel,
One is out.
Yeah, we've lost a
This
few in the
one is
last few
out.
minutes.
Yeah. Oh, no,
Okay, we just run through the just do a random thing. Okay, if the person who won it is here, then yeah, we just give it. If not, then we'll just do it again.
Okay, I think this is quite fun. Just give me a minute.
All right, let's
Okay.
spin.
Wow, the double entry one win.
All right, so Harini, I think we'll contact you, DM you. You send please send an email to us, the same email that I think we shared earlier. Maybe Edie, you want to get in touch with Harini, then we can maybe let the rest go because we need to close shop already.
Or just via Instagram, okay? If you just happen to miss this out. Okay. Thank you so much,
great.
everyone.
Thanks everyone. I think that's the end of our sharing, and well, really appreciate that you all came. Okay, really hope that you all can join us during the open house on next Saturday.
Okay.
All right, see you all.
Yep.
Bye. Bye. Bye.